Welcome back to another Orange Coast College mathematics video. In this video, we are going to be talking about using right triangles to find the values of trigonometric functions. We're going to assume that you're already comfortable with these two special right triangles. If you aren't, you might consider consulting our geometry series of videos before beginning this. So let's get started with our first example. To find the sine of 120 degrees, you first want to recognize that if you're looking for the sine of some angle, we often use theta, but any variable is fine. We're going to be either looking in a typical triangle at the opposite side over the hypotenuse side, or we can think of it in the coordinate plane as being the y value over the radius that is formed by that angle. So, considering 120 degrees, we can sketch a little picture. 120 degrees is a little bit more than 90. 90 degrees would take us to the y-axis here. We're looking at 120, so we're going to be a little bit more than 90 here. And so this is our 120 degree angle. Now, what's going to be useful for us is to use these special right triangles. We're going to want to draw a triangle from this. So what I'm going to do is I'm going to drop an altitude here from the terminal side of this angle. We know from geometry that there's 180 degrees in a circle, which means that I'm going to have 60 degrees left over for this angle here. Now, this is a right triangle, and so that leaves me with an angle of 30 degrees on this top one. And I notice now that this looks exactly like my special right triangle 30, 60, 90. And so I can fill in these missing sides. This bottom length can be 1, this top or this vertical length can be radical 3, and this radius is 2. Now, we are in the coordinate plane, so it's not really 1. We're moving to the left, and therefore we know the x value is -1. So, to evaluate this trig function, we'll go ahead and say the sine of 120 degrees is equal to the y value, which we see is radical 3, over the hypotenuse, or the r value, which is 2. And therefore, the sine of 120 degrees is radical 3 over 2. Let's try another one. And at any time, if you think that you're starting to get the hang of this, remember, you can pause the video and try one of these on your own before you see me do it. So for the tangent of 225 degrees, we recognize that the tangent of theta is equal to the opposite over the adjacent side, which is the y value over the x value. We'll sketch a picture the same way that we did before. And we'll recognize that 225 degrees is more than 180. 180 would take me here. 270 degrees would take me down here. So 225 is going to be somewhere in the middle. So we'll say this is our 225 degree angle. Now, that's the entire angle, but really what I want to do is I want to draw a triangle of this just like we did in the previous problem. So let's go ahead and drop the altitude. That leaves me with what we call a reference angle, this angle in here of just 45 degrees. Because this is a right triangle, that leaves me with 45 degrees left over. Remember, they must always add up to 180. And that lets me recognize that, hey, I'm dealing with this picture right here, this 45, 45, 90 triangle. Filling in these missing sides, we can say this must be 1, this must be 1, and this must be radical 2. Now let's take care to pay attention to any negatives. Because that we're in the third quadrant, we're moving to the left one, that's a negative x value, and we're moving down one, which is a negative y value. Therefore, the tangent of 45 degrees, or 225 degrees in this case, is equal to 1 over 1, which is just 1. Let's continue. So, secant of negative 135 degrees. Now this problem, these are all going to follow a similar pattern. They all just have a slight different twist to them. 135 degrees is between 90 and 180, but because it's negative, we're going in this direction, past negative 90, but not quite all the way to 180, so our angle is going to be down here somewhere. We have 135 degrees, and this whole angle, if I were to go all the way to this point, would have been negative 180, and that leaves me a remainder of 45 degrees for this angle, which again makes this 45 degrees, this a right angle. And look at that, we're actually dealing with exactly the same picture we had in the last problem, but we're finding the secant rather than the tangent. So we'll fill in our sides exactly the same way, -1, and radical 2. But because this is secant, we'll know that the secant of theta is equal to, it's the reciprocal of cosine. So it is going to be the hypotenuse over the adjacent, which is of course equal to the radius over the x value. In this particular problem, we're going to do the secant of 135 degrees. Using this reference angle, I'm going to get the radius is radical 2, the x value is -1. Radical 2 is positive over an x value of -1, which dividing by -1 is just really the same thing as saying negative radical 2, which will be our answer to this problem. Moving on to one more. Again, perhaps you want to try this one yourself if you think you're getting the hang of it before I do it. Drawing a picture again. Now this is interesting because we're starting with an angle of 870 degrees. We know that in the coordinate plane, a rotation of 360 degrees gets you back where you started. This is 360 degrees to come back to the beginning. So if I'm looking for 870 degrees, I can subtract off 360 degrees, and that will be in the same point in the coordinate plane. So this is 510 degrees. But which is still more than 360. So if I do 510 degrees minus another 360, I get 150 degrees. So that is the angle I'm really trying to sketch. 150 degrees we know is somewhere over here, not quite 180, but really our angle in question is 360, another 360 makes 720, and we're coming back here to end up at the same place that 150 degrees would, but we're still finding the cosine of this 870 degree angle. What that leaves me with, of course, is a reference, because we know that's the same thing as 150, that's the same thing as the reference of 30 degrees. Dropping the altitude gives me what? It gives me a 30, 60, 90 triangle, an opposite of 1, a radius of 2, and an x value of radical 3. That x value, since we're moving to the left, will be negative. So the cosine of this 870 degrees will be, it's the reciprocal of secant over here. It is the adjacent divided by the hypotenuse, which is the same thing as the x over the r, which is that negative radical 3 over the hypotenuse of 2. And that is the final answer for this one. Now here's an interesting example next. In this next problem, we're going to solve an equation. So in this problem, I'm giving you sort of the answer, and I'm asking for the angle that gives me that ratio radical 3 over 2. There's a few different ways to approach this problem, but one way that you could consider is by considering that we know sine of theta is what? We know it is the same thing as opposite over hypotenuse, which is the same thing as the y value over the r value. If I sketch a quick picture of this triangle in question, I'm saying the sine of some angle should be opposite radical 3, because the problem is giving us this is equal to radical 3 over 2. So we can treat y as the radical 3 value and r as the 2 value. Using the Pythagorean theorem, or just our knowledge of the 30, 60, 90 triangle, we can recognize that that's going to leave this side as a length 1. So maybe I didn't draw this picture to scale, but that's okay. We didn't know what it was going to look like when we started. And so now I know that I'm really dealing with, well, one possibility is certainly 60 degrees because this is a 30, 60, 90 triangle. But we're looking at all values between 0 and 360. So let's sketch a quick picture now to see what's going on. We know that the sign is positive. If the sign is positive, that means we are in the first or second quadrant, either here or here, because that's where we get a positive y value. So it's possible we could get one answer, or it's possible that we could get two answers. So I could get some angle theta here or some angle theta here. Now from the work we did over here, I know that the radius is 2, the height is radical 3, and the x value is 1. Doing the same thing on the left will give me the same values, but of course with an x value of negative 1. But in both of these cases, the x value doesn't become super important, the 1 versus negative 1, because we're just doing y over r. So, what are my angles here? Well, my angles are certainly 60 degrees. So 60 degrees, theta being 60 degrees, is certainly one of my answers. But it's not my only answer, because I could also get the angle that ends at this point on the left, and since it must add up to a total of 180, this angle is 120 degrees. So 120 degrees is also your answer. Generally speaking, it's nice to put a set of answers in brackets. And so this would be our set of solutions. On this next page, we are going to do basically the same work. The only difference is here we're going to be using radian units of measure rather than degree units of measure. Just as there are 360 degrees in a circle, there are 2 pi radians in a circle. There are pi radians in half of a circle. So when I'm asked to do sine of 4 pi over 3, the process is really the same. We're looking at the opposite over the hypotenuse, or the y value over the radius. So I start the same way and I sketch a picture. 4 pi over 3 is a little bit more than pi, because 3/3 of a pi would be the same as 180 degrees. But here, I'm looking at 4 pi over 3, so I'm a little bit past this point. So at 4 pi over 3, what is my reference angle? What is this guy here? Well, I have 4 pi over 3 in my total angle. This angle here is just pi, which is 3 pi over 3. And so that leaves me with a reference angle of just 1/3 of a pi, or pi over 3. Now, if necessary, you could think of this in degree form. Pi over 3 times 180 degrees for every pi radian is going to give me 60 degrees. So this angle here will be 60 degrees, and we're back to a 30, 60, 90 triangle. This will be 30. So opposite the 60 degrees is radical 3. Opposite the 30 degrees is 1 with a radius of 2. And so both of these values are negative 1 because we're moving both to the left and down. So now to do the sine, to do y over r, I'm just doing negative radical 3 over 2, and that is my answer. Moving on to tangent. we'll proceed similarly. Set up an axis to help you sketch a picture. 5 pi over 4 is a little bit more than 4 pi over 4. So we're looking at an angle down here with a reference angle of 5 pi over 4 minus 4 pi over 4, which is left with pi over 4. So I have a reference angle of pi over 4 here. And pi over 4 is a fourth of pi, which should be the same in degrees as a fourth of 180, which is 45 degrees. So we're still dealing with a 45 degree, 45, 90 triangle. You could also do the same conversion I did here if you want. Pi over 4 times 180 degrees for every pi gives me 180 degrees over 4, which is 45 degrees. But in any case, this special right triangle is -1, -1, radical 2. For tangent, you'll remember is opposite over adjacent, which is y over x. So the tangent of 5 pi over 4 is going to be -1 over -1, which is +1. Continuing on. For secant, we'll remember that the secant of any angle is the reciprocal of cosine, which is the hypotenuse over the adjacent, or the r over x. In this case, 11 pi over 6, how many sixths of a pi do you need to have the full unit circle to have 2 pi? Well, that would be 12 pi over 6. So this is just slightly less than that. 11 pi over 6 would end up down here somewhere. This is 11 pi over 6, which leaves me a reference angle of pi over 6, which is the same thing as 30 degrees. So I have a 30, 60, 90 triangle again. So we'll fill that in. This is going to be radical 3, -1, because the y value is going in the negative direction, we're going down, and a radius of 2. This, of course, means that the secant of 11 pi over 6 will just be hypotenuse 2 over adjacent radical 3. If you wish to rationalize your denominator, we can multiply that by radical 3 over 3 to get our final answer of 2 radical 3 over 3. This next example is interesting because we're actually finding the cotangent of pi. Pi is exactly half a full rotation. Cotangent of pi will be taking the cotangent of the angle that goes from here to here, pi radians. What that means is we don't really have a y value. We're not drawing an altitude. We're not going up or down. There's no place to draw to. We are already at the x-axis. So how does this work? Well, the cotangent of pi should be the reciprocal of tangent. So we should be looking at the adjacent over the opposite, which should be the x value over the y value. Now in this case, the x value can really be anything we want, anything along the x-axis. But the y value is specifically 0. And if we're dividing by 0, that is, of course, undefined. And so this leaves us with one last problem, which is the same as this problem we did up here, where we're trying to find the angle given the ratio. We're just doing this one in radians rather than in degrees. So for this problem, we're looking for when the tangent of x is equal to -1. We know that the tangent of x, now this is an interesting problem because x is being used as an angle here. We need to not confuse that with x, the x value in the coordinate plane. We're looking for the tangent of an x value. We know that it's -1, and we're trying to find the angle that gives that to us. Well, tangent is opposite over adjacent. And so we know that this could be comprised of what? -1 could be -1 over 1 or 1 over -1. Let's sketch a picture to see what's going on. I don't suspect that I'm going to get any angles in the first quadrant, because in the first quadrant, we have x and y both being positive values, so we're not going to get a negative. The second quadrant's a possibility, though. If we sketch a picture here with tangent of 1 being, or tangent of x being +1 and -1, because the y value is positive and the x value is negative here, we see that we get a 45, 45, 90 triangle, which of course is the same thing as 100 and, or rather the reference angle for the angle 135 degrees. So the tangent of 135 degrees is equal to -1 over 1, and therefore 135 degrees is one of our answers. Where else could I get an answer, though? I don't think it will be down here in the third quadrant, because in this quadrant we're going to get -1 and -1, which will divide to +1. But over here in the fourth quadrant, we have the y value being -1, the x value being +1, and that 45, 45, 90 triangle seems like a possibility. Well, you might say, okay, -45 degrees seems like a good value, but we're looking for ultimately values between 0 and 2 pi. So we're going to have to convert this to radians. But for our angle, we're really looking at this entire angle right here, which is basically 360 without this 45 degrees. 360 degrees minus 45 degrees leaves me with an angle of 315 degrees. So the tangent of 315 degrees is going to be -1 over 1. And so I get theta, or we didn't really use theta in this problem. I get that x could be 315 or 135 degrees. But we're looking for radians, so really I need to convert these. 135 degrees times pi over 180, and 315 degrees times pi over 180 degrees. That gives me 135 over 180 pi, and 315 over 180 pi. And if we simplify those, I get that x in this case is equal to 3 pi over 4 and 7 pi over 4. And that is my sort of set of solutions. This concludes this video. If you're ready, you can go on ahead to trigonometry 2.